case from the 1954 5.5. I recently completed on my last few videos. For you Outboard guys that have been following me, after I got the motor all running really good in the last video, it wouldn't stay in gear. So I took the gear case apart. I ended up putting another gear case on there, actually in the final run video, but then I went back to the original one. And what I found out is I couldn't get it to stay in forward, in neutral, by shifting with the shifting rod. So I was going to actually put a video up and see if anybody could chime in on what it could be. Everything is fine in the gear case. Nothing's worn. The fork isn't bent. Everything was looking really good. So just after some time, I just started thinking about it. And this was the culprit right here. The 3 notches there for the center one is a neutral. I actually measured the peak between the 2 peaks between the forward and the forward is up. The forward is up notch and reverse is the bottom notch. And this is the neutral notch. It's actually close to 20 thousandths worn than one that I compared with. So I ended up putting a upgraded stainless steel one in from a later model motor. And I don't know what year they stopped using these brass ones, but the lesson learned, they're subject to wear, and I'm sure some of you guys out there in the field have come across that problem. First time for me. So I put a stainless steel one in there inside the gear case, and everything works fine now. So no more problems with that. That was the first item. Again, the teeth. About between 15 to 18 thousandths worn on these 2 peaks, so it would not stay in neutral. It just automatically, especially with the spring that rubs against here with the tension, would just push it into forward or reverse and no neutral. And that's how I got the motor originally from the gentleman from Facebook. But my next little project here that I've been doing, I always wanted to do this, I never did for years, was make a pressure tank fitting tool. All of a sudden the inspiration bug got me and I decided to do something about it. Now I've changed O-rings with these connectors through the years by just using a small screwdriver and a pick. You actually could do it without taking them apart. But then I decided, let's make a tool and do it the right way. Now you can buy a tool online for around $30, $40, but I decided to make one because that's what I like to do, is make things. And so I took a piece of as you can see here, I had a piece of scrap aluminum from my old working days when I was working in the aircraft parts business. And I cut it on a bandsaw, the 3 pieces, to get rid of the ends. And this is the tool I made. Basically what it is just a holding tool. And you have to buy this. I bought this rod on Amazon, 3/32 rod. I think it's stainless. Yeah, it's stainless. But that's the rod you need to act as a tool. And you cut it about this length. I don't know, it's about 3.5 inches long. And you put it on this tool and you pound out the guts on both sides. Sometimes you got to use a little heat, especially if the pressure, the fitting hasn't been used in a lot of times, in a long time, and is near this, salt water. These 2 I actually had to use heat to get them apart, just a little bit, around here, to get the brass bushings out. But what's inside basically is pretty simple: 2 springs, 2 washers, 2 plunges, and the 2 bushings that house the O-rings. I got 2 new O-rings here, and I did buy new O-rings online. I think I got these I got a good deal on these. I can't remember the name of the place. A place in Michigan. They're like 95 cents a piece. Everybody else was selling for $3 or $4 a piece. So I bought 14 of them. I think it was about $10. Because I couldn't match any of the O-rings in my O-ring sets that I have, the special O-rings. So anyway, that's all done. Here's some spare parts from the ones I took apart. And I made this little puncture tool here to lay out the the initial pilot holes. Well, I made this template out of rubber mat. Basically what I did is I put this on a piece of cardboard, and once I had the guts out of one of these fittings, I just put it like that and gave it some good smacks, and it made slight little impressions. Then I took my little Harbor Freight hole puncher kit, you know, those little chisels you buy, the little set, and I just punctured those 2 pilot holes in there. And then I laid it on top here, I marked it, and I drilled it with a 1/4-inch drill bit. And they came out, you know, a little bit offline, but all in all, it works. So after you take it apart, you just put all the guts back in. Spring first, plunger. I'm sorry, spring, washer. Get this right. Yeah, plunger, washer, and then you put your O-ring inside of here. And you carefully, you look down inside the fitting here, and you'll see the hole. You got to make sure the spring goes in that hole. You don't want to smack it together if it's not in that hole. So you make sure it's in the hole. Then the washer. Well, that one's on the floor. I'll pick that up later. And then the O-ring. You put the O-ring inside the bushing, and the flat end goes up. Then you just smack it together. I don't want to put it together because I'm going to sandblast and paint these fittings. But that's basically how you do it. It's pretty simple. Just note when you take it apart how it goes. Bushing, washer, plunger with the point up, and the spring goes in like that. But you just want to make sure your spring is inside the hole inside the tank fitting. Anyway, I made this, and I think I used like a 238 pin here. These were 1/4-inch holes. These were 238. I actually used a drill bit for this because I did not have a pin that size. So I just kind of took an old drill I had. I forgot what size drill it was. Anyway, 238 will work. Well, this will slide right on there nice and easy. And either a 1/4-inch or slightly larger for here. And that goes down like that. And then you could tap the stuff back together. Now the tool you buy online, they machined it where they had the little screw holding this tool on there. But like I was saying, the original one that you buy, which I believe was copied from the original OMC tool, had a slot in here, and this was stowed away when you weren't using it with a screw. I'm just gonna throw these in my toolbox. Anyway, this is pretty much the what I've been doing, because it finally got cool here. Like yesterday was the first day. I don't know, 10 days. It was high 80s and 90s. Ridiculous. Just too much to do anything really, you know, unless you have an air-conditioned shop, which I don't have. So, but anyway, that's these 2 items. Also, I forgot to mention, I did spend some time with measuring thing. I took measurements, and I believe my final drill for these holes I used wasn't 19/32. I upped it to, I can't remember the size now. 39/64. Well, the trickiest part in this job here is just getting all this laid out properly, because you could use a caliper, but you're just not going to be able to do it right. So I figured the best thing, again, a little additional tip here I forgot to mention. You can knock out all the guts and then take this piece right here, and on a piece of gasket paper with a rubber mallet, you could probably make an impression. That's what I'm going to try to do anyway. I haven't tried it yet, because this is pretty sharp here. So the gasket paper should make an impression of the exact layout of these holes, because that's very important to make this tool work properly. And I didn't do that, so I just kind of like, fished around, and took a lot of measurements, and I got it to work. But it's not 100% precise, but it works great. So, like I said, these holes are larger, of course, than the bushings. You don't have much meat here. This whole tool just won't be backed up properly if you just go too big with these holes. I mean, there's leeway, but just be aware of that. But I did take time to make measurements. Just so you know, these bushings here, if this helps you out, if anybody wants to make one, it's 560, the OD on it. So you'd have to use a drill probably 15 thousandths larger to drill the holes, whatever that is. If it's 560, 575 drill bit, whatever that is, you have to look on a drill chart. You can drill out the holes for that. Again, this is like 238 on the pin here. This was all hand laid out. I just kind of laid everything out from taking measurements off of here to get it close. And, again, it wasn't perfect because the drill bits will walk. And I did use a drill press on all the holes. And I finished these 2 holes off here with a countersink. Just put a little chamfer on it. But all the holes were drilled on my drill press, which I dug out of hibernation to do this. It took 15 minutes anyway. But I did take a good hour plus just laying out all these dimensions and getting this thing, so it'll work properly. All right, just wanted to add that on there. An update on my 57 motor project that I started months ago. I haven't touched it since the last video. I haven't tried to start it. I did order paint for it. Paint's on its way. I'll probably get the paint tomorrow or the next day. They upped it to $30 a can. So I bought 2 cans. But I'm going to start it first, and then I'm going to paint the whole midsection and the bottom. And give you the update on that and show you how it runs. But again, with this brutal heat, I know everybody's been getting hit with the heat all over the country. It is July and August, so that's just the way it is. I'm looking forward to getting this thing going. And I did find decals for the faceplates without buying a whole set, so that's a good thing too. But just stay tuned and all right.